Hi, in this video we want to consider important ideas and related problems for JMO, Junior Mathematical Olympiad, for Junior SMO, let's say Junior Singapore Mathematical Olympiad. And we want to solve similar problems from AMC, BMO, SMT, from Stanford Math Tournament, HMMT, Harvard, MIT Math Tournament, AMC, American Mathematics Competition, BMO, British Mathematical Olympiad. And also this video is useful for all parts, junior, senior, and open section, but we will focus only on problems of junior SMO. And these are, for example, there are 9 parts, 9 ideas. We will consider each idea and related problems. First idea, second idea, third idea, up to last idea. Okay, casework. So let's start. And let's focus on idea 1. Considering small examples, we have 2 problems of junior and 1 problem from AMC. Considering a small example is so much useful. Means what? When you see a problem, you try to check small cases. So let's try first problem, junior SMO 2022. Problem number 5, last SMO or junior part. If n can take the value of any positive integer, how many distinct values can the expression this take? Okay, for this problem, we consider what it says. If n can take the value of any positive integer, how many distinct values can the expression this take? So we consider, because n is positive integer, the problem says we consider n1 first. If we consider n1, it will be 0, 0, 0, 0, 0. So we can have 0. If we consider n2, you will see again it's 0 because the denominators are 4, 7, 14, 20. So the first thing that changes these things, n4, it is 1, 0, 0, 0. It is 1. Now, if you consider n7, again, it will change. It is 1 minus 1, it will be 0 again. For n8, it will change because it will be 2 minus 1 equal to 1. N9 will be same. Same means all parts are equal to n8 for n9. And n10, 11, 12. 12 because it is multiple of 4 will change. 12 over 4 is 3 minus 12 over 7 will be 5. 12 over 7 will be 1. Here 0 is 2. Now next part, n14. For n14 it will be 3. It will be minus 2 minus 1. Okay. 3 minus 2 minus 1 is 0 again. Now next number that is multiple of at least one of them is n16. n16 will be 4 minus 2 minus 1, which is 1. Then n17, 18, 19, 20. 20 is multiple of 4. So let's consider n20. It will be 5 minus 2 minus 1, which is 5 minus 3, 2. N equal to 21. It will be 5 minus 3 minus 1 will be what? 5 minus 4, 1. N equal to 22, 23, 24. 24 will be 6 minus 3 minus what? Minus 24 over this is 1, which will be 6 minus 3. Minus 1, it will be 3 minus 1, 2. And 25, 26, 27, 28. If you consider 28, it will be 7 minus 4 minus 2 minus 1. So it will be 0 again. And if you check in 29, again it will be 0. And let me tell you something. We have 4, 7, 14, 28. As you can see, it's important to consider it is multiple of each of them. So what is the LCM of the multiple of all these denominators? 28. And if you consider n equal to 28k plus r, okay, n equal to 28k plus r. And let me tell you one important thing. If m is integer and x is real number, we can take integer number outside the floor. So if n is 28k plus r, then n over 4 here, n over 4 minus n over 7 minus n over 14 minus n over 28 It is equal to what? We replace n with 28k plus r, 28k plus r, which r is the remainder, and r is from 0 to 27. Divided by 4 minus 28k plus r divided by 7 minus 28k plus r divided by 14 and minus 28k plus r divided by 28. And if you calculate this part, 28k over 4 is 7k. It is integer, we take it outside. 7k plus r over floor of r over 4. This over 7 will be 4k. Minus 4k, you take it outside, minus r over 7. Next one, 28k over 14 is 2k. Minus r over 14. And let me just check. Yes, minus, all of them minus. Minus next one is 28k over 28k minus r over 20. And you can see 7k minus 4k, 3k minus 2k, k minus k, 0. So we can cancel this. And it will be what? It will be r over 4 minus r over 7 minus r over 14 minus r over 28. Okay, and it will be exactly the same as n. So we understand only remainder is important. And for remainders, different remainders, we've reached 0, 1, and 2. 3 different values. So the answer is 3 is C. Okay, now it was first problem. Next problem. Junior SMO 2022. So let's solve this one. Okay, next problem is 23rd problem of Junior SMO again 2022. How many integers n are there in this 1, 2 to 2022 such that floor of cube root of n is a factor of n. So here we will check if n is 1. It is what? It is 1, and because it will be 1, it is 1, floor of 1 is a factor of 1. Next one, cube root of 2. It is 1 point something, and floor of that is 1. 1 again is factor of 2. So if it is 1, it will be okay. So up to which number is 1? Up to 7. Cube root of 7 again is 1 point something. And it is 1, so all these numbers are good. But from 8, cube root of 8 is 2. So look, by a small example, we will understand the pattern. It is 2, 2. 2 is a factor of 8. But for 9, it's not good. Why? Because it will be, again, floor of 2 point something, which is 2. 2 is not factor of 9. And cube root of 10, again, it will be good because it is floor of 2 point something, which is 2. It's good. So up to which numbers? So here we have 7 numbers that are good, okay? And from this part, up to cube root of 27 is 3. So cube root of 26 again is, if you calculate, 2 point something is 2. And here only even numbers are good, okay? So it is good. 26 to 8, you say 26 only even numbers. Minus 8 divided by 2 plus 1. This is how you should calculate the numbers. 26 minus 8 is 18. 18 over 2 is 9. 9 plus 1, 10. Now for rest. You consider what? Cube root of 27 is what? Is 3. Again, all of them are 3 up to which number? Cube root of 64, which is 4, so cube root of 63 again is 3. So here only multiples of 3 are good because it should be factored. So 63 minus 27 over 3 plus 1. 63 minus 27 is what? Is 36. Okay, 13 minus 76. 5 minus 2, 3. 36 over 3, 12 plus 1, 13. Now cube root of 64, which is 4, 2, cube root of 125 is 5, so up to 124 is 4. So again here, 124 minus 64 over 4 plus 1. This one is 0, 60. 60 over 4, 15 plus 1, 16. And cube root of 125 is 5. Up to 216 is 6, so up to 215 again it's 5. So you should consider 215 minus 125 over 5 plus 1. 75. 85, 90 over 5, which is 19. 18, 18 plus 1, 19. Now we should continue. Cube root of, let's write it here, cube root of 216. So as you can see, we don't need to write like this. We say, okay, we know minus 216, and from 216 up to 6 cubed is 216. Let's write the numbers. 6 cubed is 216. 7 cubed is 49 times 7, which is 7 times 9, 63. We have 6. 7 times 4, 28 plus 6, 34. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1000. 11 cubed we should calculate. And here it is 1 over 2, 2 over 8. Okay, so 11 cubed. If we calculate, okay, 11 cubed is 1331. And if we calculate 12 cubed, it will be 1728. And if you calculate 13 cubed, it will be 2197. Okay, so up to this part is needed. So let's calculate this part. Is as you can see, for example, here, 215 minus 125 means 1 less than this. The next one is 342 minus 216. It should be multiple of 6. So it is divided by 6 plus 1. The next one is what? 512, which is 511 minus 343 divided by 7 plus 1. Next one is 8 cubed. We've considered 9 cubed is 728 minus 512 over 8 plus 1. Next one is 999 minus 729 divided by 9 plus 1. Next one, 1330 minus 1000 divided by 10 plus 1. Next one is 1727 minus 1331 divided by 11 plus 1. And last part, we know that we should subtract minus 1728 divided by 12 plus 1. But we know 2197, we consider our numbers are from what to what? From 1 to 2022. It has also another solution with telescoping rule, but I want to tell you with basic methods. 2022. So we should find the first number that is multiple of 12. 2022, if you divide it by 12, it will be 11282. 6 times this 72, which is 10. 102, which is 8 times 12, 96, which the remainder is 6. So we understand 2016 is the last number that is multiple of 12. 2016 minus 6. Now we should calculate all these numbers and add to the previous numbers. 12 minus 6 is 6, and 3 minus 1 is 2, and this over 6 plus 1, which is this number. If you divide 21, 21 plus 1, 22. Next number is 11 minus 3, 8. 10 minus 4, 6. 4 minus 3, 1 over 7 plus 1. And if you divide, it will be 2, 28, 4. It will be 25. Next one is 8 minus 2, 6. 2 minus 1, 1. 7 minus 5, 2. Over 8 plus 1. Okay, if you divide by 8, it will be 2, 56, 7, 28. And if you divide this one, 9 minus 9, 0, 9 minus 2, 7, 9 minus 7, 2, over 9 plus 1. It will be 30 plus 1, 31. And here it will be 0, 3, 3, 30, 330 plus over 10 plus 1. 33 plus 1, 34. And this number is 1727 minus this is 6. 12 minus 3, 9. 6 minus 3, 3. Over 11 plus 1. If you divide, it will be 36. Plus 1, 37. And this part, 60 minus 8 is 8. And it will be 0, 10 minus 2, 8. And this one will be 9. 9 minus 7 is 2 over 12 plus 1. So if you divide, it will be 224 plus 5, 25. Now we should add all these numbers. So let's add 7 plus 13, 20, 30, 46, 46 plus 10, 56, plus 9, 65. And so up to here, it is 65. So 65 plus 20, 85 plus 2, 87, 107, and 112, 132, and 140 up to here, 171. Next one is 5, 0, 205. And if we calculate this one, it will be 12. It will be 4, 242. And this one, 7, 429, 426, and 2. And the answer is 267. If, for example, the number was larger or you wanted, you can consider, you can say, for example, n cubed. As you can see, we've considered n cubed minus 1 for these parts. Minus n minus 1 cubed divided by n minus 1. Okay, or we can say, for example, n plus 1 cubed minus 1 minus m cubed divided by m. Okay, and then if you want to calculate this, you can say it is equal to m cubed plus 3m squared plus 3m plus 1 minus 1 minus m cubed. You can cancel this, cancel this, cancel this, divided by m. So it was 3m plus 3. And for all these parts, you can say, okay, our answer, and because we have also plus 1 here, plus 1, plus 1, it will be 3m plus 4. Okay, so as you can see, all of them are 3m plus 4. And we could calculate it without calculating all these parts, solution 2. So let me cut it. For solution number 2, you say, okay, 3m plus 4, and it starts, let me tell you, from 7. Okay, so sigma m is from 1 to last part. Last part is what? 37, which is 3 times, if you subtract 11, as you can see. 11, 3m plus 4, and you need to only calculate last part. This one, this 25, plus 25. You don't need to calculate previous terms. And then you say, okay, it is what? It is 7 plus 11 plus 237 plus 25. Now it is arithmetic progression. You say first one plus last one times the number of terms over 2. Number of terms is 37 minus 7 over the difference is 3 times 2. Oh, sorry, it is 10. Over 3 plus 1 plus last part 25. Okay, so here 7 plus 37, 44 over 2, 22 times 30 over 3, 10 plus 1, 11 plus 25. And now it is 22 times 11, 22, 242. It is 242 plus 25, which is 267, and it is so much easier. But considering a small example helps you to understand the problem better. Now, one problem is left for this part. And let's solve this problem. Let me. Okay, AMC 12A 2021, problem 20. Okay, for each positive integer n, let f1 of n be twice the number of positive integer divisors of n, and for j greater than or equal to fj of n equal to f1 of fj minus 1 of n. For how many values of n less than or equal 50 is f50 of n equal to 12? It is for American mathematics competition for recent years 2021 and also 12A. But we will solve exactly with the idea that we use for junior SMO. Here we say okay. And the problem says f1 of n be twice the number of positive integers. So if we consider f1 of, for example, 1, it will be what? Twice the number of positive divisors. 1 has 1 positive divisor, so f1 of 1 is 2. f1 of 2 is what? 2 has 2 divisors, so it's twice that is 4. Okay, now, so 1 goes to what? Under f1 goes to 2. Okay, under 1f. f50 means by this one you should consider f50 is 50 of n. You should take f1 of f1 of f1 of for 50 times f1 of n. So for 50 times. Now we know 1 goes to 2, 2 goes to 4, and we want to see after 50 steps they go to what number? f3 is 4, so f of prime numbers go to 4. Okay, f4 is what? f1 of 4. 4 has how many divisors? 3 divisors. 1, 2, 4. 2 times 3, 6. So 4 goes to 6. Now f1 of 5, because 5 is prime, f1 of prime numbers is 4, because they have 2 divisors, and it will be 6. Twice that will be 4. If we consider f1 of 6, f1 of 6, 6 has how many divisors? Because look, the number of divisors, 2 times 3, you say 1, 1. 1 plus 1 times 1 plus 1 is 4. Number of positive divisors, but you should multiply by 2, it will be 8. So 6 goes to 8. Okay, now 7 is prime goes to 4. And 8 goes to what? f1 of 8. 8 has how many divisors? 1, 2, 4, 8. It has 4 divisors, so twice of that is 8. So 8 goes to itself. So we understand all these numbers are bad because after 50 steps we want to reach 12. Okay, so prime numbers, all these numbers are bad. Let's consider 9. 9 is similar to 4. Look, because 9 is p squared. 3 squared, 9 goes to 6 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've checked. 10 is similar to 6 because it is pq. 2 times 3, 10 is 2 times 6, goes to 8. 11 is a prime number, it goes to 4. But 12 is different because it's the first number that is p squared times q. f1 of 12. 12 is what? It's 2 squared times 3. And the number of, it is 2 times number of positive divisors. 2 plus 1 times 1 plus 1. So it is 3, it is 2, 2 times 3, 6, 6 times 2, 12. So 12 goes to itself, so it's the first number, first good number that we found. 13 is not good because 13 is here. 14 is not good because it is like PQ, goes to 8, 15, not good, 3 times 5. 16, let's check 16. f1 of 16. 16 is 2 to the 4. It has 5 positive divisors times 2, 10. So 16 goes to 10, and 10 is here. So 16 again is not good. 17 is a prime, not good. 18 is p squared times q. It's exactly like 12. 18 goes to 12, it's good. 19 is prime, is here. 20 is again 2 squared times 5 goes to 12. 21 is PQ, is like this. 22 PQ. 23 prime number. 24 we should check. f1 of 24. 24 is 2 cubed times 3. It's 2 times number of positive divisor, which is 3 plus 1 times 1 plus 2 times 4, 8. 8 times 2, 16. So 16 is here, so we understand 24 is not good. 25 is p squared, like 9, like 4. It's not good. 26 like pq, it's not good. 27 is similar to 8, p cubed. 28 is 2 squared times 7. 28 is good. 29 is prime, not good. 30 is the first number that is product of 3 primes. It's 2 times, because 30 is 2 times 3 times 5. It's 1 plus 1. The powers plus 1 times 2, because the problem says twice that. It's 8 times 2, 16. 16 is not good, so also 30 is not good. 31 prime. 32 is something to the power of 5. So f1 of 32, 2 to the 5, it has 6 divisors, 2 times 6, 12. So 32 is good. 33 is PQ, not good. 34 PQ, not good. 2 times 17. 35 PQ. 36 is P squared, Q squared. Is the first number that is P squared, Q squared. 36. So it is 2 squared times 3 squared, twice number of positive divisors. 2 plus 1 times 2 plus 1, 3 times 3, 9 times 2, 18. And we should see 18 is good or not. 18 is P squared Q. And we know that it is good. So 36 is good. 37 prime, not good. 38, 2 times 19 PQ, not good. 39 is 3 times 13 PQ, not good. 40 is 2 cubed times 5. It is similar to 24. 2 cubes times 3, 24. It goes to 16, not good. 41 prime, not good. 42 is similar to 30. 2 times 3 times PQR, not good. 43 prime, not good. 44 is P squared Q. Like, for example, 2 squared times 3, like 12. It's good. 45, again, it's 3 squared times 5, 45, good. 46 is PQ, 2 times 23, 47. It says consider up to which number less than 50. 47 is prime. 48 is 2 to the 4 times 3. We should check that. 48, F1 of 48. 48 is 2 to the 4 times 3. So it is twice times 4 plus 1 times 3 plus 1. It is 4 times 5, 20. 20 times 2, 40. So 40 is, here we've considered it's not good. So 48 is not also good. 49 is 7 squared, P squared, not good, like 4. And, okay, and 50 is P squared times Q. Is 5 squared times 2, it's good. Okay, so 50 is good. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me tell you something. Here, for 48, I written 3 plus 1. You should write 1 plus 1. Because the power is 1. So it's 2, 2 times 5, 10, 10 times 2, 20. Okay, and we know 20 is good, so 48 is also good. So let's calculate the numbers. Good numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the answer is 10. Okay, there are lots of other problems that can be solved with considering small example IMO problems. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Second idea, LCM GCD prime factorization. We have 2 problems of juniors and 1 problem of AMC. You can do it on your own, because if you had questions, send message to my WhatsApp number. Third idea, Vieta's formula, Newton's sum, quadratic equation, and properties. Again, 2 problems of junior, 3 problems. 1 problem from AMC, 1 problem from Stanford math tournament. I released a video, the solution of this with Newton's sum. You should learn that. Also, it is AMC 12A 2021 related to these things, and you can solve these problems. Next one is considering blocks. How many integers are there in these, such that at least one of the digits of n is 2. And this problem is for British Mathematical Olympiad. Both of them can be solved with the same idea. You should know blocks. This idea 5, because I forgot to say blocks, is idea 4. Okay, order. For all of them, you should consider pairs, and you will see again in 2023 Junior SMO. It is groups. It is useful also in IMO, in Junior SMO 2022, and in AMC 10 and 12 2022. You can see I released the video, the full solutions of AMC 2022. You can see that video, and these two problems can be solved with the same idea. Next idea, telescoping rule. You should know Junior SMO 2021, AMC 10B 2022. I released the solution of this problem. You can see in my channel, and AMC 12B 2018 also it can be solved with telescoping rule. Remainder when divided by 2, 3, 5, the rules are what? And it is from Junior SMO 2021, it is AMC 2021 12A, and it is for AMC 2021 12A again, and we can solve these problems. Caseworks, it is so much important. In Junior SMO 2021, two problems can be solved with this idea. And also this problem of Harvard MIT math tournament can be solved with this. These problems of AMC 2022, I released the solution. Let me tell you this one. I will solve Harvard MIT math tournament, but let's review first. And also in geometry, we have some other formulas. Okay, and if you 40, 50 important formulas that are useful in junior, senior, open section. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. So let's solve last HMMT 2023. It says compute the number of ways to tile a 3x5 rectangle with 1 1x1 tile, 1 1x2 tile, 1 1x3 tile, 1 1x4 tile, and 1 1x5 tile. The tiles can be rotated, and tilings that differ by rotation or reflection are considered distinct. Okay, so when you want to consider cases, consider the most restricted part. For example, here 1x5 is the greatest one. 1x5 is on top or bottom or middle, mid-row. So if it is on top or on the bottom, both of them are same. So I consider this and multiply by 2. And next case is here. When you want to consider case works, when you say it is here, 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 don't calculate this part and at the end calculate this one again. Try to draw both of them simultaneously, okay, like here. Then, so 1x5 we draw. Now, if you want to draw 1x4, in this case, 1x4 can be here, or here, or here, or here. We have 4 cases. We multiply by 4. 1x4, then it is 1x1. And here, 2, 3. 2, 3, or you can switch 4 times 2, 8. Now let's consider this case. I want to draw 1x4. It is here, or here, or here, or here. So we multiply by 4 again, and we draw 1x4 like this. Then in this part, we have 1x1 or 1x2. So we should consider both cases. So it is like this, then like this, then it is like this one, or like this. Now here is for 1, 2, 3. Again, we have 2 cases here. And here it is 1 and 3. You can switch 2 cases here. So 2 plus 2, 4. 4 times 4, 16 times 2, 32. 32 here, plus 8, 40. So we solve this HMMT Harvard MIT Math Tournament 2023. And let me tell you some ideas for geometry. There are 40, 50 important formulas for geometry. You should know Thales theorem. It's useful in many problems. You should know Pythagorean theorem. You should know double Pythagorean theorem. For example, AMC, last AMC was useful. And these are the basic things. Sine law, cosine law. You should know how to work with angles, means inscribed central, all these angles around the circle. And also we have some formulas it's good to learn. For example, median squared is b squared over 2 plus c squared over 2 minus a squared over 4. So I'm sure like last SMO, I released a video preparation before the exam, and many ideas were useful again in 2022. Here, I'm sure 100% that again, you should use some of these ideas for the following exam. Junior SMO 2023, and also some of them useful in senior and open section. If you want to learn all the important ideas that are useful, like these ideas and solving related problems, as I said before, feel free to send message to my WhatsApp number in the description and comments. Thanks for watching this video. Have a great day and bye.